Well, hello everybody and welcome back. We have another exciting addition to the channel. As promised, a little bit more information on the Hantek handheld 2-in-1 oscilloscope DMM model 2C42. I've had a chance to play around with it a little bit more, play around with the manual, and it's coming together rather nicely. I need to stay focused though, so I took some notes because it's way past my bedtime. When the sun is that high, it's way past my time to be off in La La Land. So we're going to get right into it. I'll try not to go so fast that I sound like I'm under the influence of some various forms of speed. So we're just going to go ahead and turn this on and get this thing rolling. It boots up really quickly. If you watched the previous video, you probably already saw that. So we're going to go straight over to scope right away because we have some functions that we need to check out. So as of right now, I have a signal coming out of my signal generator, but we're not hooked up to it. Right now our probe is just sitting off to the side, and I'll tell you why. It's because this thing, though it does not have the arbitrary waveform generator that I was hoping to get, as explained in the previous video, it does have a reference signal that is basically hooked up to this, what's marked as the Awg BNC connector on top, and that is why they give you this fancy schmancy little cord. So, or split connectors here. So I'll go ahead and hook this up, and we should get a square wave. And I don't have that right in front of me, but I think it's 2 volts peak to peak at, I don't recall the frequency, so let's not worry about it. Let's just hook her up and see what happens. What do you think? And there it is right there. Looks like it's going to be 400 hertz. So go ahead and set this in. Make sure that our probe is in times 10, because the first thing that we'll want to do when we get our scope is attenuate our probe. We're going to want to make sure that we're properly compensated, and we do that by adjusting the small screw right here in the probe. I'm not sure if you can see that or not. There's a small hole with a little slot screw, and we didn't get a screwdriver. I was a little irritated by that, but most probe kits come with a screwdriver like this. And if you want to use 2 channels at the same time, you will need to get a second probe, because this only comes with 1 probe. We have 2 connectors up here. I can't turn it because of everything that's hooked up, but you're going to want to attenuate your probe correctly. So here we go. Right now we're good, but if you were to get into this screen and see that your waveform looked a bit funky, looked like maybe it had a couple too many at the brewery, maybe something like that, yikes. Yeah, we don't want that. So we're going to need to adjust that with this screw right here. So let's go ahead and make our adjustment. And if you go too far, you'll start to dip down. And basically, this is every oscilloscope. You know, if you don't have one, or if you've never done this before, you're going to do this on every probe for every oscilloscope. So, and you can see now where it's kind of rounding. This screwdriver doesn't exactly fit 100% properly, but we're going to make it work. Eventually. Okay, so go ahead and make our adjustment, and we're just going to flatten that square wave out so that it's completely square, and that is close enough for government work. So we're now properly compensated. Excuse me. Past the bedtime, and the throat gets dry, so we can go ahead and disconnect our probe now. And notice our signal is gone. So we'll go ahead and I'm going to hook this back up to the waveform generator up on top of the bench. Bear with me, as we are now ready to start receiving some signals. It is just that simple. he says. Oh, well, that's a horrible signal. What's going on? Well, we don't have our ground hooked up. Now we have our ground, and now we have a wonderful signal. I'm going to spare you from looking up at the Tektronix scope right now because you would go blind in the camera. But right now, the Tektronix scope up on the shelf is reading peak-to-peak voltage of 4.08 volts. And if we look over here, I'm going to try and zoom in on this just a little bit more. Probably might have maybe done that before. I'm always surprised at how much the camera actually picks up. I just have the viewfinder on the back of my camera, and it doesn't do a very good job of showing me what you see. It's not until I upload it. But up here we've got our measurements, and yeah, it's kind of bouncing 4.0, 4.08, 4.0, and that's exactly what our Tektronix is doing. So we're looking pretty good. Did we already? We turned off already. Look at that. Okay, so you know what? We can fix that. Let's make sure that doesn't happen again. We'll go right into the menu, and we will go to our backlight time, which is set for infinite. Let's go to our shutdown time, and let's go to infinite. So now they can't shut us down, brah. So let's see here. Well, let's just start with our menu. Okay, so we have English language, or perhaps if you speak Chinese and can read that, yeah, a goat with a dog barking at some chopsticks. I don't know what any of that means. I'm sure it's wonderful, but you just hit that button again, and we're back in English. We can turn our sound on or off. We have our backlight, which is adjustable, so we can turn that up if we want. And it just cycles through the more you push the button in one direction. So I usually have a tendency of setting mine about right in the middle, but we'll go a little bit brighter just because of the outside. So let's see. We can save waveforms, and then we can use those waveforms as a reference waveform later. And this will store 6 different waveforms, so that can come in pretty handy. Let's see. We have cursor measurements, so we can go ahead and go into our cursor. We can select whether we want time or volt. We can select what channel, and obviously we're only using channel 1 right now, so but you're able to enable or disable it there. And then we can move our cursor, so you just select the cursor that you want to move and press up or down, and if you just press and hold, it'll move rather quickly, and then you can just adjust it. So if we want to set our other cursor, we can just pull it down like that, and that's pretty close. So and it's giving us an increment of 4.12 volts. So it's nice. I like it. Let's see, we're right back over there again. Let's go. If we want to measure, that's how we turn that function on or off. So if we press that way, if we enable it, then we'll get our measurement back. And then you can go get your system info right here, which is just giving you the model number and blah blah blah. And then calibrate. Now calibrate, I'm not going to do this, but it's pretty funky. You press the calibrate button. When you do this, when you calibrate, make sure you have everything disconnected. You don't want any. I'm zooming back just a little bit too far. You don't want the. Oh no, I hit the auto set button. That's okay. At least it wasn't calibrate. You don't want any of your probes hooked up when you do your calibration, because you can damage the scope, or possibly just throw off your calibration. So nobody wants that. Let's see. So we can do some basic things with the time base, but just by pressing the channel that you want to. So if we had both channels selected, you could go back and forth and just you're going to press your left and right arrows, and that will change your volts per division. And then you can go to your time base, and the same thing. Now you also have YT mode, you have roll mode, which is lovely. You have your Scan, oh, well, that's right, scan isn't available on this one. Then this gives you your depth, you have 3K and 6K, and then we also have bandwidth limiting, which is not in this field, but let's see if we can find that. That is our hold button, essentially, which will stop it from rolling. Let's go ahead and just auto set another waveform here. Oh, we're still in 10 and 10. Hang on just a second here. There we go. So now obviously we're not adjusted correctly because our waveform just disappeared. Let's fix that. And there we go. So now we're in one, and you know what? We need to adjust that in our probe menu. Remember our probe menu? Where did our probe menu go? Well, I thought I knew where I was. Going back over here. There it is. So times 10, and we need to be in times 1. Okay, so now we'll be measuring correctly, and everything should be wonderful. So we have our trigger setup that we can go into, and we can set our trigger on slope, or we can go rising. I think it automatically is on rising, I believe. And then we can go to auto mode, or we can go to normal mode. And then you can actually force the trigger too if you need to. If you're not getting it exactly, you just, it's basically going to act as an acquisition button. So, okay, what else? What else can I tell you? The AWG function does not work. So you can press that all day, and you're just going to get that. This model has no AWG. Fine, whatever. As far as you can save your selections. And I haven't quite got this mastered yet, but it involves this button with the little man, which, who wants to gender label, I guess, but still, looks like a little dude, just chilling there staring at you with no eyes. Apparently, if you do a long hold on that, you should be able to save all your settings, and then you can recall those later, so that's nice. Oh, the calibration. Just checking my notes real quick. The calibration, I calibrated it 3 times, turning it off, turning it back on, and then running the calibration. And I all 3 of those times I used a stopwatch and then averaged them together. And the average that I got was 2 minutes 17 seconds. Excuse me, 2 minutes and 17.656 was the average. And literally it was like 217.61, 217.69. There was probably less. Probably my finger hitting the buttons was more of an error than anything else. So I would bet you it's pretty darn close every time it runs a calibration. Let's see. So we probably demonstrated the menu, the trigger functions, channels, time base. Probably. Just to save time, we are going to go into the DMM functions, and I have some things set up so that we can kind of check them against the other meters. Now, we should probably, I should probably explain the other meters. Let's zoom out a little bit so that you can see them. These other 2 meters are the ones that you will always see these on the bench. I have more meters than I can find, but these 2 are always going to be on the bench. This is the chosen one that we use for almost everything, because of its functionality and accuracy. For what I do, this thing is, you can't get much better perfection. And one of the reasons why is I spend a lot of time where I have floating voltages in audio equipment. I want to be able to see the AC and DC voltages at the same time, and with the press of a button, I can do just that. So that's very, very handy. And it's also, we're not going to get into the functionality of this one, but this is just the base, the meter that I have running most of the time and eats up all of my batteries. This has been selected because it is also, this is a true RMS meter. This is also a true RMS meter, and while this Tektronix even used and scuffed up and beaten is $100 probably if you're lucky enough to find one, this one is about 20, which is much more affordable, and surprisingly, they're very, very close in all the values, which is why I kept this one. So I had a couple of these before this, and I blew one up. Don't ask how. Moving on, the other one was just a little bit off. This one is very close in most measurement applications to the Tektronix. There are a few variances aside, but for the most stuff, DC voltages and whatnot, they're actually generally pretty close. So what I've done here is I've set up some batteries. So we're going to start with our DC voltages, which on this one you just have to. We have to make sure that we're in DC. So we've got DC and AC. So we'll go back to DC, and I'm just going to measure this 9-volt battery, and try and keep the probes out of the way as much as possible. So you can see that we have 8.26 volts. So now I'm going to pick up the probes for the Tektronix. We're going to go to DC voltage. Might as well keep it simple. And same, we'll measure across, and we have 8.27 volts. So again, very close. So let's go check our accuracy to our this meter. And we're going to go to DMM. We're already on DC volts. I have taken the broken condom tips off of our probes. Make sure we see everything here. Try to keep everything in the shot. And measure across 8.28 when it settles off. So these are, you know, that's close enough again for government work. Perhaps if you're using if you're working in a very high pressure, high precision lab environment, this you wouldn't have bought this anyway because you got all kinds of bucks, right? Just you know, just joking. So let's see. So that was our 9-volt battery. So let's go ahead and repeat that process just for guns and games. This is what usually these are really good references. Look that up online. Start with the Chinese Smart V. Used to have a Vici around here somewhere too. I don't know what happened to it. Okay. This is not the way I would normally do this, but there's usually not a camera in the way, so bear with me. We'll try and get a quick voltage here. 1.355. Now clearly these batteries are toast. That's why they're sitting out here like this. 1.355. As a matter of fact, probably should be able to hold that. We'll remember it. You'll remember it, right? You can remember it. I can't remember it, but you will. Let's see if I... And 1.355. So let's go ahead and go to our new 2-in-1 China meter. .35. Well, it climbed a little bit there. Some capacitance from let's check this. Let's check this one more time. Let's set this right here. Get my thinner off of it. Yep, climbed up just a little bit. So still pretty darn close though. I would once again say it probably works as a DC multimeter just fine. So let's go ahead and check our AC. Now what I've done here is I've hooked up a I'd run everything through an isolation transformer, and we have a variac of sorts. It's a variac, but a variac is a brand name. It's an auto transformer. The Diode Mode by, I think that's Dayton made that one. As soon as I find the end of my extension cord here, come hither, little tither. There you are. So we can go ahead and essentially just, so we're going to go ahead and switch our voltages over to AC. There's AC, here's AC, and here's our extension cord. We're just going to plug them all in at once. So this is going to be the China meter first, our cheapie. This does not want to stick in there very well. We have 121.0 Let's move around a bit. We'll do that. And now we're going to plug in our Tektronix. Look at that. Just following right along with each other. So, only one more to go, and luckily we only have a couple of holes left. So let's fill them. I always like to start with the ground first, because I like excitement. Ooh, don't want to do that yet. We're not in the right voltage. Why did you almost let me do that? What's wrong with you? Okay, here's our AC voltage selection right there. So if you notice, and I noticed this earlier, it doesn't really want to move around a lot. It's much slower, but it does eventually settle off on a voltage. So I think that's one of the things where you kind of have to play around with it just a little bit. So there you have it. And still pretty darn close. So let's go ahead and unplug these. Well, apparently that one's had a little to drink. Come on, Lush, you got a job to do. Stand up. I don't care what your wife did. Just do your job. Okay, so let's get plug this and plug this. It's got a pretty cool feature. Yes. Again, you can snap your fingers and that'll thing will come on. Of course, it never worked when I needed to, but well, whatever. Okay, so what other? We've got a couple other components. Oh, should we go ahead and check the amperage? Let's check the amps real quick. So I have a fan, just a small computer fan, and it's hooked up to some wires. That's generally how you do it. And we're going to pump a little bit of a voltage in here. I think. This one is set. Let me turn this. Let me turn the juice on to my power supply first. I think it's at 10 volts and something like. Let me look here. There we go. 10 volts. 10 volts on a current limited supply. Not a very good current limited supply, but it'll do the job. So we're going to go ahead and hook our little cheapo meter in circuit. We can go ahead and without explaining too much here, we can use this. This is 10 amps fused, but we have. Make sure that's not the right meter. I gotta switch this one. There we go. Yes, we can use milliamps on this side. So we've got our voltage, ohms, milliamps, diode, and hertz. And since this is under an amp, we can go ahead and use this one. So I will hook one probe to our ground and the other to our power supply, and we should get some fan spin at some point. Oh, wrong setting. Watch. There we go. And our fan takes off, and we're getting 92.7. Looks like it's going to settle off at 6, 7. Yeah, it's right around there. 6, 7 milliamps. So go ahead and disconnect that. And we're gonna skip that. We're just gonna shut this Tektronix off for a minute. No sense in wasting batteries. And yes, I did change the batteries in this before I started, which is why I didn't want to use one of the flukes either, because I didn't have any more batteries. And those are not new, so probably off by just a little bit. So let's go ahead and go to our DC amperage. And we'll go to milliamps. So there we are. Now if you see right here it says milliamps, we need to switch this over. It actually gives you a little diagram right up there. It tells you where you need to be. So we'll go ahead and pop this connector out and put this connector, this port, just cross everything over. The equipment loves that. Make sure our banana plugs are properly secured. We'll go to ground. And then we'll come over here to our power and see if we hit fan spin. There's fan spin. .7, just really close. Now, and this is already in the milliamp range, so you know, I'm not gonna complain about that. I won't complain about that at all. So I'll go ahead and disconnect this one. We're gonna skip the amperage. It's and I am still looking. We're gonna find out this weekend because the teardown is a coming. I'm not gonna have time to do it again today. It's way past bedtime, but this weekend I will be. And my weekend starts on Thursday, so anytime after tomorrow, you can expect to see a video, and we're gonna take this thing apart. I'm very excited to see what's inside of it. Okay, so we have this. Let's see what other components. Let's go ahead and move into the component testing. So we'll come back around here to ohms, and we will go on this meter to ohms, right there. And this is just a resistor. It should be a 1 kilo ohm resistor, I believe. And its value should be very close. So, excuse me, 10 kilo ohm. Well, you made a liar out of me, didn't you? Here, let's zero these. Okay. Check this one more time. 9.99 kilo ohms. So 10 kilo ohm resistor. Let's check with our Hantek. Oh, yeah. Why didn't you tell me to move the connector back over? You guys aren't being much help here. That's alright, I forgive you. Forgive me too. Okay, ready? I'm having a hard time keeping this thing. There we go. 10 kilo ohms. Now that is a first, and I wonder, I bet it's because I'm probing into that pad. Let's get that off of the pad. There you go. Off of the pad, we're nice and steady, 10 ohms. So, just for guns and giggles, let's see what the Tektronix has to say about all that. Back up here. It should be ohms. I can't see. It's in the... turn the light up. There we go. Okay, so now we're in ohms mode. And let's go ahead and see what the Tektronix has to say about this. 10 kilo ohms. So, I think, shut this off and turn it back on. Probably get a more accurate reading this time around. Still low. Who'd have thunk? Alright, well, maybe our battery's starting to go. I just put one in, but these things, that's one thing I know. These things will suck up some batteries. They get real inaccurate real quick. So, let's see, what other components we have. We need diode mode. Now, we get into diode mode and capacitor mode, and this is where my meters start to diverge just a little bit more than usual. So let's go ahead and go to diode mode. Yeah, of course not. So you notice we've got our buzzer, or we have diode mode. That's how this one works. So let's just go ahead and I've got some Shenzhen special 10 volt DO35 Xenier diodes. Let's see what those measure at. And we had apologies. I'm not used to probing around a camera. It's very difficult. You wouldn't think it is, but it actually is. 0.791 volts is where it settles off at. So let's go ahead and probe across with our with our 2-in-1 Hantek.